Hey, all right. This is John Park, and this is John Park's workshop. Welcome, everybody. I hope you enjoyed the tunes. I'm hoping I played them for you. I was having some last-minute insanity of deciding to switch up my little live music setup. I've got a couple of pocket operators as well as a Nintendo DS playing Electroplankton, running through a little D Studios mixer thingy and having a lot of fun with that. So let me take that music out there, and I want to welcome you for coming. Let's switch that view up to what we're going to be talking about today. Involves joysticks, but not just joysticks. Also, let me switch out to this view. Also, servo motors and a little webcam. So I decided to build a little pan tilt camera mount so that we can control two axes of motion, just like that, on a camera remotely, or by wire, I should say. However long the length of your wires is would determine this. You could do a wireless setup. That's not what we're doing today. And so this is going to be based on the FeatherWing, the PWM Servo FeatherWing that can control up to 8 servos. So this could be something we could really expand. Lots of cameras, or pitch, roll, yaw, that kind of motion on the camera. So, but today we're going to do it with 2. I think we'll limit it to that. And let's see. I think before I forget, I want to mention today's coupon code, which is Pan Tilt. So that'll get you 10% off in the Adafruit store on anything you want to buy, with the exception of gift certificates. And probably you can't use that on subscriptions to, well, I know you couldn't use it on subscriptions to software when we do carry software in the store. I don't think you can use that on a subscription to Adabox either. But anything else in the store, that's good for today for viewers of this show, and that will get you 10% off of the entire cart. So go to the store if you were thinking of getting stuff armed with this coupon. Now's your chance. Let's see. I'm going to just take a second to pop open a window for the YouTube chat. I've got the Discord chat up. Hello, everybody. How is everyone doing today? Hey, let's switch over to that chat. Let's, there we are. Let's pop that in. Noe is visiting the chat today, or is hanging out in the chat today, which is awesome. And there's a little conversation going on about the fact that Noe and Pedro had their 3D Hangouts show yesterday morning, and there was coffee spillage. So I'm being cautious. Actually, normally I have my water in a bottle like this, so I'm less likely to spill, but I'm living on the edge today and have a delicious glass of filtered water. That's good stuff. Let's see. So I was going to pop open the YouTube chat, and I got distracted by myself. Hey, there it is. I got to pause that and do the pop-out chat. Hey, everybody. So how long has YouTube had this thing where there's this thing called top chat versus live chat? I guess top chat are some algorithm decides they're the most talked about items or the highest value discussions. I'm not sure how that works, but John K. got some fresh coffee, also living dangerously. Hey, everybody. Hey, welcome from Germany, Marco Muhles. I don't think I pronounced that right. So let's get going on. I don't have any thrift store finds this week, but let me go over to the workbench and I will show you something came in the mail that I'm excited about. So let me switch these up real quick. And I will show you, I got an order of PCBs in from Oshpark, right there. And while I'm at it, oh, you know what I didn't check? I didn't check if my camera switcher is working. So let me just try, make sure that I'm in that window and double check the switcher. Yes, okay. Since my camera switcher is a CircuitPython device that's plugged into my workstation, sometimes when I'm programming other CircuitPython devices, like the one for today's show, I unplug the camera switcher just so I don't have two device drives showing up with basically the same name. There'll be a little ~1 or something on one of them. So I don't accidentally overwrite the file on this. I should probably name it differently. You can do code.py, code.txt, or main.py. I think those are the three that will boot. And I usually use main.py. Maybe I'll change that one to code.py so I don't overwrite it. That would be an idea. So let me just pull up the chat over here on... Pause that. Oh, that's not the new one. That was last week's. Let's go. This, there we go. YouTube. All right, now we can see what the delay is. So there's the top chat, and I'll change you to live chat. And there we go. You can also rename the drive name. Oh, is that right? So can you permanently rename the drive name of a CircuitPython device? Does it remember that? That would be awesome. I never ever tried that even. I just assumed. Wow. That's heavy. All right, something to think about. I'm going to try that later. So back to this. I got some perfect purple PCBs manufactured in the US from Osh Park. Ready, set, make. So let's open this up. I have a bunch of little boards. I didn't design any of these boards, but I found some boards that were made by Mutable Instruments, who are a synthesizer, modular synthesizer maker. And let's move this stuff out of the way for a second. I'm going to move this camera, actually. Whoops. I'm going to tip that camera. And there you can see in the side view. So I have these little breadboard friends, I think is what they called them, right? Which are some little useful utilities when you are working on building your own Eurorack modules, synthesizer modules, which I've started diving into. And so there's, I think that one is just the 1/4 inch, or sorry, 1/8 inch jacks that you can use, excuse me, now I'm dying, to interface with other stuff. So if you're building a circuit on a breadboard and you need to get out to 1/8 inch jacks, this is an easy way to do it instead of putting alligator clips on them. Let's see. This one actually is someone else's design, which is for a little MIDI input. And I was thinking about building my own, but I wanted to check that one out first. Anyway, these are some fun little boards that I think one is a power supply that gives you roughly Eurorack power. I think it's not actually 12 volt or 5 volt, but I think it's 8, weirdly. What else are these? I don't even remember what some of these are. This is a potentiometer knob one, I think. No, that can't be right. One of these might be. Anyway, I might write up a little post about those once I actually do something with them, put it together. But very fun to get some PCBs in the mail. Okay, so now let's talk about the subject at hand and do a little bit of a build here today. So the idea I had was I wanted to use the 2 potentiometers of this style of joystick, you can see up there in the corner, to drive the angle of a couple of servo motors. Excuse me. So your typical hobby servo, this guy here, usually has a range of 180 degrees roughly, so you can turn left and right or up and down. And that is controllable with pulse width modulation. Now you can often do that directly from a microcontroller, but I wanted to try out, we have this little FeatherWing that is expressly designed to control 8 PWM'd things. So that could be servos, that could also be LEDs or other components that take a pulse width modulation control signal. So I've already put this one together, as you can see here, and I've done a little bit of little work to make it usable the way I want to use it. So first thing is I put on some male header pins, these short male header pins, so that I can connect it up to a Feather. This is a Feather M0 Express I'm using, and I want to try doing this, talking to this chip with our library that we have for the PWM on this FeatherWing. So the servo motors have 3 wires coming off of them typically for these simple servos, and those are a ground, a power, and a control signal, which is the PWM that is the command that tells the thing what angle to go to. So this has 8 of these headers. Now these are the ones that come with the board. They're little straight headers, so you can plug it in from the top. I happened to have some of these little right angle ones that I was going to use for a different project and didn't, and realized that these were kind of a recommended item if you want to plug in your servos from the side, which means in this case all of the plugs are going to come in from the sides and nothing from the top, which makes life a little bit easier when you're trying to put things in an enclosure. And we're going to come up with an enclosure for this today too. So I've soldered on these right angle headers, and that means I've got 8 possible servos I can plug in. So as you can see here, there's markings on there that make a little more sense when it's going in vertically, but ground is the brown wire on this type of high-tech style. This isn't from high-tech, but high-tech style color coding. Brown is ground, this orange is the voltage, and the yellow is the signal. So this goes in like that, and that would be the 8th plug, which is labeled number 7. We start at 0. So the other thing that you can see, a couple things I did here, there's room on the board for a capacitor. If you're going to be drawing a decent amount of current, you may want to put a capacitor on there to smooth things out a little bit. This is the power input. So we're not going to power the servo motors directly from the microcontroller, which is a bad idea in general, to drive your logic and your motors off of the same power supply, because it typically leads to things rebooting and resetting themselves. And these will draw a lot more current than the board can put out on its little 3.3 volt pin. It's also not the 6 volts, which is roughly 5 or 6 volts is what we want to drive these servo motors. So I've got a little terminal block on here which accepts a couple of wires for either a roughly 6 volt battery pack, or I'm just going to use DC voltage. So I've got, or rather DC voltage from a power supply, a little power brick. So I've put on one of these barrel jacks so that I can plug this in and then plug that into the wall to get power. Now you'll see right now I'm not plugged into the Feather, but if I plug power into this, we have a little indicator on here. Can you see that? Let's go big on this view. How about? So let me focus that too. So you can see here when I plug in my power, that just indicates that we have not power to the microcontroller that this would normally be plugged into, but just the 6 volts or 5 volts is available for the servos. So that's kind of cool. Now you can see that there are 2, actually let me grab, I have another one, hold on one second. I'm going to grab, I'm going to grab a sip of water, and I'm going to grab another, I have another one of these PWM FeatherWings somewhere. Here, let me switch cameras so that I'm not a mysterious voice. So I have a little drawer here that's probably even labeled with PWM, there it is, Servo FeatherWing. Okay. So this little guy, and I said I was going to get water, so let's grab that. This little guy has 2 rows of, oh, let me switch first camera. 2 rows of holes for connecting to the pinouts on the Feather that it's normally going to be plugged into. So into the outer edge row, I put the male header pins that plug it down into the Feather, like so. And then this inner row, it's not quite a perfect fit, but you can do it. So I've soldered in 2 sets of these little terminal blocks so that I can screw things into them. So if you look here, I'm going to refocus. If you look here, this is this inner row, and I just barely had enough of those legs poking through that I was able to solder those, which means, again, I can plug things into the board that are maybe not going to be permanent, like in this case it's the joystick that I'm going to be plugging in, I'll be able to change my mind about things and screw in connections there. So that's how I've set up the PWM FeatherWing. Now, the feather itself, let's go take a look at the code I'm running on here, because it's actually pretty simple, and then we'll do some little tests and then get to building a little gimbal here, or a pan tilt head. So let's switch over to this code. And so this is CircuitPython, and we have a, let me widen this actually, I can make that bigger for you. This is, again, broadcasting in 1080p, so you should have clearer text than usual, which I'm very excited about, as you can tell. So at the top of the file here, we import some libraries that we're going to use, and these are typical: pulling in board, pulling in time so that we can pause or delay. And then this PCA 9685 is the library for the chip that the PWM FeatherWing uses. And then we're also importing this library that makes it sort of straightforward, easy, simple commands to talk to servos. And we also have one for continuous rotation servos, and there's a third one which I'm forgetting. Let's see, do I have? Yeah, we might take a look at that also on the browser. So this is an I2C device, so you can have lots and lots of them as long as you solder a little jumper on the bottom of the board that changes its address. And then we're instantiating this PCA object for the chip, and it's told that it's running on the I2C bus with its default address, whatever that is. So the next thing I'm doing is I might change this actually. Let's we'll test it as it is, but right now I'm running the 2 channels. So I said there's 8 channels on the board that you can plug the servos into. So I'm using 0 and 7, the first and the last one right now. Those are coming in at opposite sides of the board, so I might make my life easier by putting 0 and 1, so that it actually reduces some of this sort of footprint of this board. The frequency of the pulses is generally 50 hertz for a servo, and this is working, this default is working. And then the next thing I'm doing is creating the servo objects for those 2 servos. So I'm calling the Adafruit motor.servo servo command, and then I've written these out so that you usually can get away with not typing in the name of the parameter equals, and then, but I did this to make this a little easier to see. So we've got the PWM out for the first object here is, so servo X, excuse me, is servo X channel, which up here is what I decided was 0. And then the actuation range of this servo is 180 degrees, and you can change that if you have a servo that's different. And then there's a default minimum pulse size and maximum pulse size. So the way that this pulse width modulation works is that it's essentially a square wave, and it jumps instantaneously from 0 to the top of the control voltage, which is 3.3 volts. But the timing of that change is going to determine which angle it sends the servo to. So at 1.5 milliseconds? Is it microseconds? I forget. I'll have to double check that. But at 1.5, it's at 0, so it's essentially telling the servo to stay at its center position. And then it essentially thinks of it as positive 90 and negative 90. That's why I'm calling the middle 0. So the minimum pulse here I've got set at 544. So when I tell it that the frequency spacing between pulses is this number 544, it will go all the way down to the negative 90, or you could think of it as 0 to 180, it would be 0, but negative 90 position. When the pulses have this 2500 spacing between them, then it tells it to go to the 90 degrees positive, or 180 if you're thinking of it that way. So you can tell servos I'm going to jump ahead a little bit. This little example here that I've commented out is kind of a typical way to test out servos, is just to say, hey, go to this angle. And then the library works out that it's going to send this pulse width square wave with the spacing of the one that equals 180, which in our case is what, 2500 I said? Yeah, 2500. And then it's telling it to go to 0. We're not using this because I want to use my joystick. And the joystick, let me talk about this for a second. Here's a typical arcade joystick, kind of like the one on my shirt here. It's 4 buttons. So if you look on the bottom, when I click forward, it's actually hitting one of these 4 limit switches. So that's a typical arcade-style joystick. There are a few different types of joysticks, and the one that we're using here today is a little more complicated, but it has a lot more control. There's a pair of potentiometers, so we're able to read the analog value of those pots, just like you were turning a knob. That's exactly what this guy is, from the bottom to the top of its range, and same for the other axis. So I'm considering this to be y-axis and x-axis. So since we're using this type of joystick, we need to set up the board to read analog values. So here I'm setting up 2 pins that I'm reading, which are analog input pins on the Feather. I'm reading pin A0 and pin A1, calling them X pin and Y pin for clarity for myself. And then I've got a little function here called getVoltagePin, and we can send a query to that later on to say, hey, what is pin X or pin Y, which are A0 and A1, currently telling us voltage-wise? Now, the way the potentiometer works is that it has 3 pins. It has ground going to one and power going to the other, and the center is a wiper that's essentially a variable resistor. So it's either going up towards the full voltage of 3.3 or down towards 0. So those are the answers we'll get, and it's actually 65,536 steps of analog read on that pin. So here, this is the while true. This is the loop that we're going to run. What I'm doing is I'm creating this joystick X value, which is running that get voltage command on the X pin, and then joystick Y. So now I have the answer to those 2 values. Then what I do is I tell the Servo X angle to go to whatever that joystick X is, and since the range was 0 to 3.3, I've multiplied that by 54.55, which is the math that gets me from 0 to 180, starting with that 0 to 3.3. Makes sense? It should make sense, right? The same thing happens for the other joystick and the other joystick axis, and that sends to the other servo. So I've got, as we move left, right, we'll move one servo, forward, back the other. So this code I already have on that Feather. Let's go check it out. Enough talk. Let's put this together and have a look at just that part in action. Matambale said the REPL sure is handy when you're developing and testing. If you saw in my code there at the bottom of the MU, that's the window I'm using for editing, at the bottom there's a live session of the Python interpreter running, which I can look at values, sort of like the serial port on an Arduino. So I can look at values there as I'm testing to see which way is positive and negative, and you could reverse the polarity on the joystick. So let's see. Let's take our Servo FeatherWing, PWM FeatherWing. I'm plugging that into my Feather. I can put power to, let me switch cameras for you again. I can put power to the servos, so now it can run power when it gets the command. I've got this is a nice servo. These are the high torque metal geared servos that we sell in the store. They're not that expensive. They're product ID 1142. I think they're maybe $15 or $20. And so, they're larger than the typical little micro servo, and instead of plastic gears, it has metal gears. So let me pop that out and put that where you can see it. These little servo horns. You usually get a bag of these And you can see these are typically used to move flaps on RC airplanes or steering on RC cars. So you usually get a handful of these in a bag and some screws to attach them. And these are splined, which means they essentially have little teeth in a pattern that fits perfectly over that shaft. So I'm going to put that in correctly. Put that there so that we can see this one move. Now this is on pin 0, so this is going to be the x-axis. So for my, let me pull this camera out just a little bit, and I'll rezoom or refocus. So I'm going to just connect the x-axis potentiometer here. It's kind of arbitrary. You could do this way too. And there's probably a right way and a wrong way, but you can always fix it by flopping polarity. So I'm going to set ground to about over here. I'm going to set voltage over here. And then I'm going to read, if you see here, I've got 2 alligator clip wires running into the feather, and those are on the A0 and the A1. Those are the analog pins I'm reading. So I'm going to set this green wire, which is analog 0, and that's the one I intend to read for x-axis stuff. I'm going to set that on this potentiometer wiper leg right here. So now if we put power to the feather, so I've got power running for the FeatherWing. Now I'm just plugging in a USB cable that's a wall wart to give me power. Okay, and if all has been connected properly, you can see we get this nice translation of the joystick range, which is, I think, about 50 degrees. And that's being translated to 90 degrees in each direction. So 100 is being translated into 180. And it's not hard to do. The libraries make it really easy, really nice CircuitPython library that we have. And we also have an Arduino library for this that you can use. So that gives us our x-axis, and then for the y, I'll need to plug power and ground, which I only have on this feather. I think there's 2 grounds, but only the 1 power. So rather than start attaching alligator clips to each other, what we'll do now is solder some wires to these so that we can run those in and maybe test out both X and Y. So let's switch the cameras to that and that. And I'll check in the chat any thoughts or questions. Let's see. Oh, YouTube's breaking our links? Man, why are you doing that, YouTube? Yeah, if you go, by the way, this is a little shortcut for you. If you know the product ID, so I just said, and a lot of people at Adafruit think this way, they think in product ID numbers. So 1142, you can type in adafru.it/ and that number, and it goes to the product. So it's a really short URL that we have. It's .it is the domain. So adafru.it/1142 will show you the servo. The joystick, did I show you that? I think I had that up on the screen there. I forget his ID number, but you can find that too. So let's disconnect this. I'm going to pull power on everything just to be safe. And now we'll run, excuse me. Hey, by the way, I have reorganized the shop. In fact, we'll see in a second when I get the pan tilt. I've got it pointed over here. I cleaned up the shop a little bit because I've been shooting some video related to AdaBox 007, which will be coming out. Well, a lot of people have it in the mail already, and it will be released, the unboxing, on Tuesday, this coming Tuesday, 9 p.m. Eastern Time. So tune in for that. And so in order to prep for filming, I cleaned up a little bit and reorganized some things. I'm very happy about that. You probably can't tell because my shop is full of stuff, but that's kind of how I like it. But this little area here is a lot neater. Okay, so there I've got, are you looking in this camera? Yeah, there, hello. I've got wires for my power and ground. Now, one thing you often do with joysticks and buttons and arcadey kind of stuff is you will just jumper short runs of like ground to ground and then off. You'll remember I did that with the arcade briefcase. But I don't know exactly who's going to be ground and who's going to be voltage on these because I might need to flip them. So I'm going to give them each their own wire, and then I'll thread them into the same hole on the terminal block when I need to. So let's use that to measure out. We'll keep the color scheme going, a green and a blue. Yeah, one of the things I did in my reorganization that I'm happy about is getting rid of some old empty spools of wire off of this little wire stand I have. Let's see, can I show you that? Can I point this? Let's try that. Yeah, you can see these are, my lovely little wire stand now is a lot neater than it was, and collected some various spools from around the shop. Put them into one place. I'm happy about that. Yeah, someone was asking me about giving a little tour of my shop, which would be fun to do as a video, and that was partly why I decided to do this here today, which is, we'll see a little bit of the shop when we control this little camera. All right, so I'm also happy because I got a longer HDMI cable, so I can now put this down shooter where I need to. The jump was from 15 feet to 25 feet, so now I've got a bit of excess, but I'm amazed at how far a run of good quality HDMI cable will take you. Okay, so let's prep this for soldering, and I will give you that close-up, that corner view. Let's fire up the soldering iron. I also keep my spools of solder on that same little wire dowel that I have there. So just kind of reel them out when I need them. So let's prep those. I'll try it with my little automator guy. Oh, whoops, sorry, that is a sideways view. And now it's a flipped view. No? There we go. These little auto strippers are pretty good for this silicon wire. Not for the smaller gauge, not for the 30 stuff. I like using a sort of manual focus or one-time automatic that doesn't constantly try to refocus itself, but it does mean that I have to reach out and hit that button a lot. So, wiring and soldering take time, which is why I pre-did all of those FeatherWing connections for the header pins and terminal blocks, because that just, if you can time-lapse it, great, but this is a live show, so we don't want to spend too much time on that. But this part, we're going to have to. So I will get away with, just for speed, I'm not going to tin these. I'll probably regret that. But let's see. Okay, so I'm going to connect these to, how do I want to figure this? I just want to figure this out with the alligator clips and then solder them. How about that? Okay. So going back to here for a second, let's zoom out. So I liked for X having ground here and the power on the left side. And this is actually kind of a flipped view of a potentiometer, usually looking at it from above, but we look at it from the back of it for these. So let me repower FeatherWing and the feather and just confirm that, and we'll solder those on once we're happy. So right and left. Right, left, yes. I like that. Let's do that. Let's go ahead and unplug power. And then just so I don't screw this stuff up, because it's especially easy to screw these things up, I'm going to leave the other ones on while I solder that one, and that'll help prevent calamity. So let me grab, oh, I managed to not bring any reading glasses in here. I steal them from here and put them other places. So I will just squint a little bit. That should be okay. Lovely. Okay, now I can take that off, connect one of the red wires. How are we doing on time here? 1:35. I think we'll do it. I've started to get into a cadence of projects that can pretty much be built in 40 minutes or so, giving some time for preamble, screwing things up, and so on. Now, one interesting thing about this joystick that I want to explore is that it has a, I just noticed this on the product page, I didn't try it myself yet. You can unscrew this bottom of the housing and replace, or even, I think, remove the two springs that auto-center it. You'll see this when I let go, it centers. It's a medium stiffness spring. So that's kind of interesting, because if I want to have a control where I can just leave a camera at a certain position, I don't want it auto-springing back. So we'll see if that's an option. And then this was the green wire for the x-axis. Even for simple stuff like this, it's helpful often to do a little diagram or a fritzing drawing or something like that, so you know what you're getting yourself into before you start soldering the wrong things. All right, looks good. Let's now move this a little bit. Let's screw those into the board and double check that it all works. I need to find a tiny little screwdriver that's over here. Here it is. And then we'll go through the same process for the other axis, and then we'll do it individually. And then once we're happy with the way that goes, we can twist together the ends and just dive two wires into the ground and power, and then they'll each have their own individual signal wires. Oh, am I unscrewing the wrong guy? I am. Yeah, so the pattern on this is 3.3 volts, then the analog reference, AREF, then the ground. And I'm going to leave the blue one in there so we can do that same test in a second. Oh, I should have done that now before oh well. Okay, so move these wires, alligator wires, off to the side. Okay. So, second pin here. Unfortunately, there's no visible silk screen for this. Sometimes I'll reference another feather. When I prototyped this, I actually had it on a feather doubler, which is kind of nice. That's one of these things. So you can put two feathers side by side, and it acts like they're stacked. But you can still see the feather. Okay, so now ground. This is actually a pretty good diameter of wire. What is this, 22, 26? I can't remember. This is our standard silicone stranded wire. This is a pretty good diameter for screwing into these little 0.1 pitch terminal blocks. And next one over, then I'll leave that blue one in, is going to be the green. Now the camera arm is going to be a pretty cool use for this, but you can also do with the, the fact that we've got 8 servos that we can drive from this, you could set up buttons and knobs and multiple joysticks and do animatronics or who knows what, some robotics. Okay, so I'm going to plug power. Give us a zoom out. Power for the servos, power for a feather. And let me fire up my sleepy iPad again. And now, let's hope that right is right, yay, and left is left. Okay, so I'm going to test the, this is kind of interesting actually. The way I'm going to test the other one without doing a lot of unwiring and rewiring is that I'm going to plug this into the center wiper, and then I'm going to do some alligator clipping from ground to the right one and power to the left one and vice versa, and decide which one is the proper up-down for this second potentiometer. So let me grab just some regular old jumper wire, alligator clips actually, and here I'll do ground to ground, power to power, and my other servo, this guy here, I'll put a horn on it so you can see it. I'm going to plug that into 7. Okay. By the way, a nice thing about this chip and the software on this FeatherWing is that when you set these to a position, they hold the position without doing a ton of wiggling. You often hear a servo when it gets to a position. It's constantly sort of buzzing around there. These, I don't know what the circuit is that allows that, but these work a lot more nicely. So I want this to be, whoops, the orientation. I just lost the ground wire, so it reset itself. I think I want that to be the orientation. We're going to look at our little rig that I've built before we determine this, actually. Oh my gosh, I keep dropping that one. This is a bad alligator clip. Stay there. Okay. So forward. Oops. There we go. These guys are touching each other. There we go. Forward and backwards is wrong. So I'll reverse those. So it'll be like this. You could do this in code too, but I really like keeping the code simple and plugging the voltage and ground into the proper. So now we have, let's see, forward, backward. Good. So now let's, before I commit to that, let's take a look at the rig. What I did was I looked online and I found on Thingiverse a sort of regular-sized hobby servo pan tilt mount, and I can show you that right here. And I 3D printed them. So, larger servo pan tilt arm by Robert C.L. Thank you, Robert C.L. It is really simple, and I think he was intending it for, well, you can see here, like a little Raspberry Pi style camera on a board, or maybe that's a ripped apart webcam. So just these two pieces. I had to kind of file this one out a little bit, and then I'll show you. I have, just for fun, especially because Noe is in the house, I shot a little iPad video of this as it was printing, so I'm just going to scrub that because I didn't have time to turn that into a sped up time lapse. Oh, let me turn up the music. Backwards. Okay, so there's one of our 2 brackets, and then I built the other one. So let's go back over to the workbench, and I'll show you these pieces. So I didn't have a lot of time, and one of the finicky things, if you're going to measure and model your own, let's go to big view here. You have to measure and line up a lot of holes and a lot of diameters of things, and maybe even make little splines. I've laser cut stuff like that before with splines. I don't know if you could 3D print it accurately enough to fit perfectly. I ended up super gluing the round discs that come. This is just like these servo horns. They pop on and off, so they clamp perfectly to the shaft of the servo, like this. And now we have something that can turn like that. Super glue might not be the best thing, so I'm kind of expecting to have to redo this with some real fasteners at some point when it pops off. But to test it out, let's go to this camera here and move this out of the way. Let's kind of build what the rig is going to look like. So left, right, it's going to be this one here. And I'm going to just zoom in a little for you. So I'm just clamping this in a little pan of ice. And I'll remove this servo horn. And this is going to go here. So this is how the left-right orientation is. Where's my joystick? Okay, so that would be a camera facing forward like this, facing right, facing left. Okay? And then for up-down, we'll have our other servo fit into this little side here. I'm going to switch to this little camera and arrange it again. 13 minutes. We can do it in 13 minutes. The enclosure might not be too fancy. Let's see. Let that water go. Okay, so there's going to be left, right. And then for up, down, I'm going to have this other one here, which this one's in rough shape. I had to super glue it a second time because I had a clamp still on it and went boom and popped it off. So that's never a good thing. I didn't even scrape off the old glue, so this one's doomed. But hopefully it'll live long enough for us to sort of proof of concept this. So when I pull back, yeah, so this is how I kind of expect it to work. When I pull back on the joystick, kind of like a flight control, I'm going to look up. When I push forward, I'm going to look down. Okay. And then the goal is going to be to mount this webcam, which is somewhat hefty. Focus there, onto here, so that it'll move along with it. And I'll even switch to that view so we can look through that camera. That'll be fun. So that I did all that just to make sure that I'm happy with the orientation of my polarity on the joystick, which I am. So I can pull out power and finish soldering this here. So let's go to the other top down. I can zoom a little further with this. There we go. So let's do power. Now I could do the jump straight across here. Maybe that's a better idea. Let's do that. Let's just do a short wire that runs from there to there, since we could change our minds later and that would be okay. So I'm going to shorten this up to something like that. I'll do that for ground and power. So I'm just jumpering them at the potentiometer. That means that I don't have to deal with two wires running into those screw terminals. That's one thing I've noticed about screw terminals. They don't really love to have two wires twisted together and jammed in there. They tend to not hold that well and pull out at the wrong moment. So so I don't forget who goes where, we'll solder that red wire right there. Okay. Now, I'm going to remove that and that. Can do black on the left, same shortened length, and this is going a really short little distance here, so something like that. Never ever cut a wire exactly the length that you think you need, because it always comes up short. That's what I have found. Oh, sorry, that was out of view when I was doing that. Darn it. I could really use some computer vision OpenCV software that watches my broadcast and tells me when there's nothing happening in one of the camera views, because it means I've pointed it at something and then not stuck my hands in the way. That would be nice. Or it'd be really cool if Discord could make noises. Can we do that? Because I know that you can be over there yelling at me. This blue screw terminal looks like an Adabot face. You're right. Check this little. It's cute. All right, so now this will get, I'm going to tin this since I'm about to try to solder it to something without putting it through the hole there. It'd be a little easier if I tin it first. This is like multi-view cam time here today. Okay, and that red wire is going to jump across like that. Again, I'll tin it. You can use a helping hand for this, but yeah, I also come up with this technique, I do at least, of holding the wire with my pinky and ring finger and the solder with my thumb and forefinger. Middle finger does not have a job in this scenario. And, oh, darn it, out of view again. There we go. Okay, that should be good. So now we have a nice little neat package. What's left? Blue wire, don't forget that. Yeah, so we have quite a few different joysticks in the store. There are these neat little PlayStation Portable, PSP style thumb joysticks, which also have a 10K potentiometer on them, I believe. And then we have the Xbox style thumb, kind of a bigger thumb stick, also with potentiometers. Actually, I'm not sure about that PSP one. What does that PSP one have? I think it's a pair of little potentiometers. I bet this is out of camera view, isn't it? I'm going to look up and I'm going to be mad. Darn it, it is. That's the spot. I got to put some tape on that spot. I've soldered that blue wire while I was talking. I'm very good at distracting myself. Okay, so we'll undo the... come over here. Let's go to this view. And make that big. Swatch that around. Watch out! Okay. Oh, that didn't focus. Try again. There we go. So let me swap out this wire. Did I just distract myself talking about distracting myself? I'm pretty sure I did. Okay, let's neaten that up. Let's get all these alligator clips out of here. What's our time? 6 minutes? Is that enough time? We might go a little over. I say that every week, don't I? My projects are always just in the nick of time. It does not help that I forgot my reading glasses, because I'm doing this by intuition sometimes when I can't see it very well. There we go. Okay, so wiring complete. Let's do another test, and then we will put together the hardware. So power to the PWM board, power to the Feather, about to the bigger view. Don't burn myself on the soldering iron. That's forward, right? Down, up, left, right, coordinated move. Yeah. Okay. Now, if you find that it's a little bit off from center, sometimes you live with it. Sometimes you'll build something, and the way the camera goes on, it'll be adjustable. Sometimes you can turn it by one spline. I think that maybe improved it. It might be a little cockeyed, though. So normally that's something you would try to adjust with the hardware, because that center position is that center position on the servo. It's telling it to go to middle, it goes to middle. And I suppose you could probably add some software to override that center position, but it may mean that it's constantly pinging, I'm not sure. Okay, so camera to attach. Let's pull that one from there. This one can stay. And this camera has a 1/4 inch threaded, what do you call it? You know, 1/4 inch threaded guy. I'm blanking on it. Threaded insert. Thanks me. I'm sure you were screaming that in the... Yeah, pan tilt camera rig. That's what we're making, Sci History. This little webcam, I'm going to be able to move it with a joystick. And welcome. Hello. Thank you for stopping by the YouTube today. So this is a little camera screw. What I was planning to do is just drill out a hole in here, pop the screw up through the bottom, and off we go. So all I need is a 1/4 inch drill bit and a little piece of scrap wood. By the way, I do have my hot glue gun over there primed and ready, just in case that super glue does not hold, which I'm a little dubious of that super glue. Okay, I'm grabbing a drill and a 1/4 inch bit. That's not a 1/4 inch bit. I want a really, really, really nice big giant drill index. That's what I want, with all sizes and multiples. Looks right. So drilling 3D printed PLA, always an adventure. So I will first try to line up where we're going to put this. Okay, so I'm going to trim off this tab. This was from the original design, which isn't for the board I'm using. So I'm just going to get a hobby knife, box cutter style thing, and see if I can just nick that off of there. Bong, gone. So that should now fit something like that. So we're right at the edge here. And I will get a awl, punch a little hole. I'm going to make some marks just to improve my odds. Oh, you know what? There's another little corner piece I don't need. Let's see if I can get that off here without breaking everything. That one's going to be harder, and I don't want to break this. Let's leave it alone. Yeah, we'll leave that alone. Okay, so we're going to be on like that. So I'm going to just get a marker. And unscientifically, that's my spot. Semi-scientifically. No rulers involved. And let's just I'm going to put this to the edge. I don't know that you'll be able to see it for a second here. Let's go to Big Workshop Cam. There. Just because of the arrangement of this thing, I don't want to break the servo horn off. Hey, even dropping it is a little tenuous with this guy. Okay, we'll see if a 1/4 inch hole, yeah, it'll just barely. And we might need to take something to clean that up a little. I can use a stepped reamer. It helps. You always end up hearing all those little bits of plastic inside of there. Oh, look, I'm doubled up on there. Let's go to this one on the small one. Or this little deburrer. That's close enough. Okay, so now, the moment of truth. We have a few threads there. That's enough to attach. Just like this. These are nice little photo threaded screws. I'm sure Noe and Pedro had something to do with those ending up in the store. Okay. Oh boy, is that going to clear? Yeah, maybe? I think it clears. All right. Oh, I just popped this. Get that into camera. I just popped this one out of its housing. And there's no screw holes for these. The servos always have these little screws that you can use to mount them to things, so I could add those. I have a very long USB cable running this back to my computer, and managing that I'll need to hook that to something so it doesn't get caught. All right, so let's, oh yeah. All right, let me switch to that camera and we'll take a look at this guy in action. Oh, I'm gonna hide under this USB cable here, snaking all the way back. All right, let's go to, where is that camera? Is that in QuickTime also, or did I set up a, oh, it's that one. Yeah, all right. We can do it that way. Let me just make that one big. Hold on, if you don't mind. 1920, 1080, sure. 24 frames a second. Does it do 30? Let's do 30. We'll scale it up. Set it over there. Okay. You can see actually the servo is adjusting. It's not sitting still like it should have. I'm not sure why that is actually. There we go. Point this over here. So there's that workshop view, and can I, hey, hello. Looks pretty far down. Is it going to hit anything? Nope. We have clearance. This is just right. Let's go to the right. There's the drills, and there's my computer and all the cameras and monitors. Now, this is the inception moment, man. This is the barber shop mirror moment. Be careful, you don't get sucked into that. Woo! Got some printer filament hanging there. There's a big bright light. Those are all spools of filament that are down, hidden behind those. That's some little components and microcontrollers. Hidden behind those is where my Ultimaker is, which is what I printed this on. I've been getting back into my Ultimaker, as I know Noe and Pedro have, because I have a 2 Plus. Because the Type A machines company folded, so I'm a little nervous about it. That's the other one I had, is the Series 1 Pro. All right, we have camera action. Let's put this view back in place. Whoops. what am I trying to do? How about that one? So you can see the thing in action again. Hey, he's looking up at you. That's creepy. Kind of cute. Yeah, so it's very servo-y. You know, you don't get super gentle, smooth motion from this kind of hobby servo. It's only got so many steps to the gears. But super cute, and he's looking at you. So that is gonna do it for today, huh? Is there no way to do smooth pan and tilt? Yeah, you can use the either higher end servos maybe, but more typically a stepper motor, which has can have micro steps and much smoother motion. So yeah, there are a lot of pan and tilt rigs out there. If you look at everything that's on a drone or a quadcopter or octocopter, those all I'm pretty sure are going to be using steppers and not servos. But servos are pretty convenient for this type of project here, and easier to mount to. Oh, I am hitting a little something there. Okay, this would need to come out a bit. I can actually do a little bit of adjusting that camera webcam. This is a little Logitech webcam. There we go. Now I'm fully cleared. All right. You can see if you look in this view from the side. Let me go to the big camera. You can see that this here was bumping into the pan servo when it was heading back. So I was able to, the camera has its own little built-in adjuster. So that fits really well. So did not get to building an enclosure today for this. Sorry about that. I didn't have anything super fancy in mind, actually. I was going to put it in a plastic Parts Pal box, which I looked and I think that would fit pretty well. I might fix that up at some point and bring it back on the show. But that pretty much concludes building the pan tilt servo, and I will take any questions or comments over in the Discord and YouTube chat for a minute here. And I want to thank you so much for stopping by to check it out today. That's not the Discord chat. That is. So, where did I actually put my Discord chat? Yeah, the streaming camera controls, I should add this. If I used, there's a lot of fun projects you can do with this. Right now, I didn't even get a chance to look at the springs in the bottom of that, but you could have it so it stays oriented where you move the joystick. Maybe with this kind, there are other joysticks that are a little more suited to that, where there's a little more friction and they hold their position. You could also use a wireless Bluetooth or maybe a Wi-Fi feather so that you could do control over IoT. So the typical sort of web-controlled webcam, we could post that up. That might be fun. So I appreciate the comments. Yeah, I think that's all we've got for today. Okay, well, I'll be hanging out over in Discord for a little bit longer. And I just want to put in a plug real quick for AdaBox 007 unboxing, which is going to be next Tuesday night at 9 p.m. Eastern Standard Time. And the unboxing will be probably 45 minutes or so, I think. We aim for trying to keep it under an hour. So I'm going to show you all the great contents of that AdaBox, as well as some of the projects that you can build. And then also on the following night, Wednesday night, I'm going to be doing a special edition of John Park's workshop in the time slot that is normally our Ask an Engineer, because Phil and Lamore will not be able to do the show that evening. So I will be there. Don't be confused or concerned. I'll wear a pink wig and grow a beard so that no one gets panicked. So thank you again so much for tuning in, and I will see you next week for AdaBox unboxing. By the way, subscribe to AdaBox 008 now so you don't miss it, and you can join in on the fun next time. Also, one last thing, this is our code for the week or the day for 10% off in the Adafruit store. So if you have a cart full of goodies, be sure to use this and get 10% off. All right, well, thank you again so much, and I will see you soon. Bye.